In 2024, Microsoft, Google, and Amazon together committed over $200 billion to AI infrastructure, and every serious analyst called it the entry fee. Pay up or you're out. Apple spent roughly $10 billion, and the name that keeps coming up whenever people imagine who should lead Apple through the next decade is not a software visionary or an AI researcher. It's a hardware engineer named John Ternus. That's not just succession gossip. The kind of leader a company chooses is usually a strategy statement written in human form. When every other major tech company was racing to build the largest AI model, Apple was studying the financial reality underneath the race. Think about what it actually costs to stay in. You spend tens of billions building a data center, and the second the building is ready, the models inside are already outdated. The next generation demands even more compute, so you start paying for the next data center before the first one even opens. That cycle doesn't end. That's how Google, Microsoft, and Amazon ended up in a race where stopping isn't really an option. The large model companies want to be the single entry point for all digital traffic, and both Microsoft and Apple arrived late to that race. The question they're both asking is the same: how do you claw back control of the entry point traffic? NVIDIA saw this clearly from the hardware side. By equipping home PCs with dedicated AI chips, most inference needs can be handled locally without traveling to a data center at all. Apple and Qualcomm reached a similar conclusion from the phone side, and the reasoning rests on facts that are hard to argue with. Ask your phone to find the photo of your daughter in the red jacket at the beach. Sending that request to a data center is often the slowest and least private way to solve a problem the phone is already standing right next to. And underneath the privacy argument sits a physics argument that's even harder to dodge. For a device you interact with 300 times a day, any delay over 100 milliseconds feels laggy. Over a lifetime, waiting through hundreds of millions of these tiny lags adds up to hundreds of days of wasted human life. For some tasks, that delay simply doesn't work. Real-time voice translation can't pause while your voice flies to a server and back. But the commercial logic is even more critical for Apple. The higher price you pay for AI chips means you are paying for the compute power, saving Apple from building massive data centers. And when these chips handle the tasks locally, the data never goes to the cloud, keeping the profit with Apple instead of AI software companies. OpenAI understood the threat of on-device AI early. It never bet that a stronger server-side model would be enough to keep users from settling for a smaller, free model right on their phone. The reported device project with Johnny Ive, the rumored chip work with Broadcom and TSMC, the infrastructure deal with SoftBank, and the public move into robotics all make sense only if you believe that on-device compute on phones poses an uncontrollable threat to OpenAI's cloud services. Microsoft's situation is structurally different and more complicated. Microsoft gave OpenAI enormous resources, including cloud computing, distribution through Bing and Office, and billions in cash, because it wanted to leapfrog Google without building a frontier research lab from scratch. The partnership delivered real benefits, but OpenAI never intended to stay a component inside Microsoft's world forever. When Mustafa Suleyman hinted that the partnership had cracked, it left Microsoft in an awkward spot, too dependent on a partner that had moved on and too far behind the frontier to close the gap fast. The Microsoft-OpenAI fracture made one risk very visible, very fast: the risk of feeding a competitor with your own money and the risk of depending on any single outside model provider. This is part of why Apple chose Gemini to power Siri. Apple's bet is simple: push on-device AI to the limit, and cloud AI becomes just a nice-to-have. At the consumer level, the race isn't about building the biggest model anymore. It's about hardware companies capturing the largest share of on-device AI users. Whoever controls the first point of contact between human intent and the machine owns the gate. They get to decide which AI service, local or cloud, actually gets the traffic. Beyond its massive user base and brand premium, Apple holds several cards. This isn't just a defense against AI giants. It gives Apple the native capabilities to intercept and redirect their traffic. Apple's privacy and security standards are among the strictest in the world, and that reputation is itself a strategic asset. Picture a radiologist at 6 in the morning reviewing a patient's lung scan. She wants AI help comparing a suspicious spot against thousands of cases in the literature, but she can't send the file anywhere because it carries the patient's full identity. Or a lawyer working late on a confidential contract. He wants AI help spotting risky clauses, but he can't paste the whole thing into any AI service because it holds both companies' names and the deal price. These aren't edge cases. They're the shape of most serious knowledge work, where the most valuable part of the task is also the part people least want a stranger to read. The phone itself can erase the patient's name from the scan, swap every sensitive project name and deal number for a random code, send only the clean version to a cloud model, and restore the real details after the answer comes back. The cloud never learns who the patient is or what the deal is worth. Which turns the question into this: how does Apple securely hand over private data to the AI services that actually have the expertise? The answer is a system Apple calls private cloud compute, and the best way to understand it is through what it prevents. When your request needs more power than your phone alone can give, it has to go somewhere. The AI industry's default assumption is that somewhere is a cloud server run by whoever built the model, where your request is logged, your patterns are studied, and the company learns a little more about you with every conversation. Apple built its own data centers specifically to break that flow. When a request from your iPhone needs to go beyond the device, it first goes to Apple's own servers, gets processed there with no record of who sent it, and only then, if an outside model like Gemini or GPT is needed for the actual reasoning, does a stripped and anonymized version reach them. Apple designed these servers so that even Apple's own engineers can't read what any single user sends through them, and the software on those servers is opened up to outside security researchers, which is Apple's way of proving the privacy promise is real, not just marketing. The result: any AI company that wants Apple's users has to run as invisible infrastructure. No direct relationship with the user, no view of who's asking what, no way to turn Apple's users into their own audience. To see why that matters commercially, think about what a position like this is worth. Uber shows up every time you need a ride. Amazon shows you products the moment you're ready to buy, and neither pays Apple a cent for that prime spot in your life. Now imagine asking Siri to order a Mac, and it handles the whole transaction without ever showing you which retailer filled it. Over time, you might forget that Amazon as a website ever existed. It quietly fades into a warehouse with a shipping department. The longer arc of this strategy comes into focus when you line up what App Store economics were against what intent economics might become. For years, Apple's most valuable software position has been built on routing. The App Store routes commerce. Default search routes information. Apple Pay routes payment. Maps routes movement. Messages routes social life. And the operating system quietly turns intention into app usage. The App Store model is a fixed toll on routing through a gate, 30% of most digital transactions. What Apple is building now is different in shape: control over the moment before a person decides what to buy, where to go, or whom to trust. The value is no longer just a cut of completed transactions. It's a position upstream of the decision itself. Picture a user who no longer opens apps the old way, but just says, "Get me home, but pick the option under $20." Or, "Order the detergent I bought last time, but only if it lands before Thursday." Or, "Find a hotel near the meeting, skip the noisy streets, and put it on my company card." In that world, Uber, Amazon, Expedia, Maps, Mail, Calendar, and the payment apps don't disappear. They just become the delivery crew behind an assistant that talks to the user first. This doesn't have to replace Apple's existing revenue overnight, but it widens the business from a passive cut on finished transactions into something more active: the power to decide which service gets the next high-intent user. The exact way to make money from this is still open, and there's a structural reason it stays unsettled. AI serves the user, and its promise to the user is honesty. Advertising serves the merchant, and its promise to the user is only visibility. Those two promises are hard to keep at the same time. The strategic shape is already visible. On-device model first, Apple's private cloud second, an outside model only when needed, and the user relationship staying inside Apple's interface the whole way through. The business logic follows the technical logic. If AI mostly runs in the cloud, the user pays a subscription and the AI company pays the data center bill. If a large share of AI moves onto the phone, the user pays for stronger hardware, and Apple captures that value through memory, silicon, battery, and device upgrades. Apple Intelligence requiring 8 GB of memory is no longer just a comfortable spec. It's the entry ticket to on-device AI. And as models grow, the memory requirement could climb right along with them. A small local model sounds light, but a 7 billion parameter model squeezed down to 4 bits still takes roughly 4 GB before you count the operating system, apps, cache, and context. That's why more RAM in the phone suddenly stops being a line on a spec sheet and becomes an AI product decision. Memory prices are rising, and so is the memory an AI phone needs. Two multipliers pulling the same way. This is why John Ternus makes sense as the next Apple CEO. It's not about building a foldable iPhone. It's because on-device AI has run straight into a wall of physics. Turnus has been involved in the architecture of every iPhone generation, closer than almost anyone to the whole system. Not just the chip, not just the case, but the place where they meet and the trade-offs made in that space. AI chip debates that obsess over TOPS can mislead you because TOPS is easy to print on a slide, while real inference depends on how fast the system can feed data to the compute units without draining the battery or cooking the chassis. The industry is already heading this way. Microsoft's Copilot plus PC standard demands a 40 TOPS NPU, a bar anchored by hardware like Qualcomm's Snapdragon X Elite at 45 into 8 TOPS. Against those plugged-in PCs, Apple's A18 Pro in the iPhone 16 Pro delivers 35 into 8 TOPS under the tight thermal limits of a phone. Those numbers matter, but they aren't the whole story. A chip that can run plenty of operations but can't move model weights through memory fast enough is like a fast factory, with a loading dock too small for the trucks. The work is ready, but it can't get out the door. This is the memory wall, and in AI, it gets brutal. Every token the system generates means touching huge amounts of model data, so bandwidth per watt can matter more than a pretty peak performance number. Apple's advantage isn't that TSMC hands it magical physics, because Qualcomm, MediaTek, AMD, Nvidia, and others can buy the same advanced manufacturing. Apple's advantage is that one team designs the chip, the operating system, the frameworks, the memory behavior, the thermal limits, and the shape of the device, all as one system. Nobody else does that. On the Mac, Apple's unified memory lets the CPU, GPU, and neural workloads share one high-bandwidth pool. The iPhone can't just become a Mac, but the same direction shows up in smaller form. More memory, smarter caches, compressed models, and data paths built around real inference instead of a marketing benchmark. When people say HBM-like logic is moving to the device, the right picture isn't a phone using the same memory stacks as a data center GPU. The right picture is the principle of high bandwidth close to compute moving downward, into personal devices. This is where Turnus enters the story, because he's the one who decides how aggressively the entire product line gets rebuilt around that chip. If the iPhone needs more memory for local AI, someone has to swallow the higher cost. If the neural engine has to run hot for long stretches, someone has to redesign the thermal budget. If cameras and microphones become AI sensors instead of simple input devices, someone has to make the case. The battery, the privacy indicators, and the software permissions feel like one product. Apple's board choosing a hardware engineer as the next CEO is a bet on the next category, and that category is the home robot. Apple's position in robotics is structurally different from its position in the phone, and that difference makes the problem more important, not less. The reason is physical, not commercial. A phone can tolerate a few hundred milliseconds of delay when it fetches an answer from the cloud. The interaction feels a little slow, but nothing breaks. A phone mostly handles structured or semi-structured data: text, photos, messages, documents, calendars, locations. A robot inside a home has no such tolerance. Robots live in the physical world, where gravity never takes a break, and a wrong answer can mean a broken plate or a hurt child. For home robotics, on-device compute isn't a preference. It's a requirement. A robot can't phone home before deciding not to step on the dog. It can't upload a full map of the bedroom for every move it makes. And it can't wait for perfect Wi-Fi before deciding whether a falling glass is worth catching. The technical names are visual SLAM, three-dimensional reconstruction, semantic mapping, sensor fusion, tactile feedback, actuation control, and embodied reasoning. The human version is simpler. The machine has to know where it is, what things are, what can break, what can move, and what it should never touch. This is why Vision Pro is more interesting than its sales numbers. As a consumer product, Vision Pro has obvious problems. It's expensive, heavy for many people, socially awkward, and still hunting for a broad daily use. As an engineering platform, it's a different thing. It pairs an M-series chip with an R1 sensor chip, takes in cameras, sensors, and microphones, builds a low-latency understanding of the space around it, and tries to make digital objects behave as if they share a room with physical ones. Apple has described Vision Pro's sensor-to-display path as around 12 milliseconds. That's not just a comfort number for the headset. It's the kind of timing discipline that matters when perception has to become action. Vision Pro isn't a robot, but it taught Apple's engineers how to make machines that understand physical space, with low-latency perception, hand tracking, and room mapping. Apple's hesitation in the automotive market left a permanent scar. While Apple wavered between building its own factory and becoming the underlying software layer for global cars, Tesla seized the ecosystem, closing that historic window for good. Many analysts view robotics as the final act of the EFI race, given the deep overlaps in battery tech, electric motors, and autonomous driving pipelines. This makes entering robotics a far tougher fight for Apple than the car market ever was. When Apple first looked at cars, the incumbents were legacy giants like GM and Ford. In robotics, Apple faces Tesla, OpenAI, and Xiaomi, agile IT behemoths with relentless market speed and elite software execution. If Apple wants a home robot, it cannot afford to start from scratch, and it won't. The path will be built directly from the components it already owns: iPhone sensors, Apple Silicon, Vision Pro spatial mapping, app intents, on-device models, and PC C-style privacy routing. It comes down to this: whether Apple's next decade is defined by services sitting on top of hardware, or by hardware becoming the ground that AI, identity, payment, health, spatial computing, and eventually the physical machines in your home all stand on. This is the deeper reason Ternus fits the moment. John Ternus leading Apple is, at its core, a declaration. Apple is moving from a consumer electronics company towards something harder to name: the local layer of compute that a person's intent passes through before it reaches any AI, any service, or any machine. The last thing a person touches before any of it gets involved. The coming decade of competition, in hardware, in AI, and eventually in robotics, will be fought over who builds and owns that layer.